the value of a normal random variable. Our objective, we want to find, using StatCrunch, and interpret the value of a normal random variable. Previously, we were looking for the area under the curve, which represents probability and proportion. In this video, we are going to be given the area as a percentile, and we're looking for the actual value, the number along the horizontal line. So let's talk about what we know. We know what percentile means, the value below which a percentage of the data fall. And we know if X is a normally distributed random variable, the area under the curve represents two things. One, the proportion of the population with the characteristic, and two, the probability that a randomly selected individual from the population will have the characteristic. All right, as I was just saying, in addition to allowing us to find the area under the normal curve, StatCrunch's stat calculator's normal allows us to find the value of a normal random variable that corresponds to a certain proportion, probability, or percentile. And normally when this is done, we're going to give them the percentile because that's how people will talk about it, and we want to find the value. Let's take a look at an example, and I think it'll help it make a lot more sense. Example number 1, the scores earned on the math portion of the SAT are approximately normally distributed with a mean of 516 and a standard deviation of 116. Letter A, draw the normal curve, shade the area that indicates the 20th percentile. Okay, letter A. I will draw the normal curve. And I hope I do better than I've been doing in the past a little bit. That's not too bad. Okay, that's it's not easy to draw the normal curve by freehand, as I'm sure you've realized. That's pretty good. Okay, and I'm simply going to label the mean. The mean is 516. Shade the area that indicates the 20th percentile. So the whole area is 100 percentile. Or this is because the 20th percentile is 0.2. The whole area is 100th percentile. Okay, everything's in there. This is the 50th percentile. This line represents the 50-50 line. Let me go up a little bit for you. And so 50th percentile, 50% of the data are below the mean. 40% will be below approximately here, 30% approximately here. So we'll go right to here and we'll shade in this part and we'll say that that's approximately the area that represents the 20th percentile. 20% of the data is below this. Okay, and that area, as we know, is equal to 0.2. Which means all the white area on the right here, we'll just make a note here, this area, I can write a little bit clearer than that. This area is equal to 0.8 because the total area is 1. We know that. Everything on the normal curve is 1. So this one gives us the area that represents about the 20th percentile, somewhere over here on the left. And the question becomes, we've done letter A. Okay, we've shaded that. Letter B. Use StatCrunch to determine the score for a student at the 20th percentile. So the question becomes, what is that score? What does X equal? Because that score will give us the 20th percentile. Okay? So we want to use StatCrunch to find that, and StatCrunch will do it for us without too much difficulty, actually. We'll put in the area, we'll put in 0.2, and it'll give us that number. So let's go to a fresh StatCrunch sheet, and let's get into our normal calculator. Stat calculators, whoops, I got to press it again, and then normal. And we've got the default. The default, of course, is kind of giving us a mean. Let me come up here. The default gives us a mean of 0, standard deviation of 1. It's defaulting. Well, we're going to change that. We want to use our data. Our mean is 516. Our standard deviation is 116. Okay. We want to know percentile, so we want to leave this symbol because we want to know percentile is below, and that's the less than symbol. We don't know what that number is, but we do know the area is 0.2. Okay, so we're going to put 0.2 into here and press compute. And there we have it. Here is the diagram we just shaded. Remember, here's the mean. So there's the high point right there. And we shaded our diagram off to the left. I may have been a bit more to the left than they are, but we were just approximating. Okay, but our diagram does look like this one. This is 20% of the data, 0.2. This is 80% of the data, 0.8. And if we look down here, it tells us that the SAT score rounded to the nearest whole number, because that's how SAT scores are done, would be 418. So a student who scores 418 on the SAT math portion will be in the 20th percentile, which is right here, 0.2. Let's go back to our paper. So now we know what X is. Letter B. We need a score of 418. Use StatCrunch to determine the score for a student in the 20th percentile. A score of 418 results in an area of 0.2, which is the same as the 20th percentile. 0.2 is the proportion and the probability of being in that range right there. Okay, letter C, excuse me. Use StatCrunch to find the middle 90% of math scores. In other words, basically between 5% and 95%. That's the middle 90%. If we look at this diagram, we know the middle 90% is going to be between my fingers, kind of like here. 5% over here, 5% up here. So we're going to be between 5 and 95 to get the middle 95%. 95 minus 5 is 90. So we're going to have 5% above, 5% below, or between 5 and 95. All right, StatCrunch will do that for us. Let's go back to our StatCrunch, which is already set up. And I'll go like this. First thing we do is we want to be between. So we need to come up here and choose the between option. And then we'll come down. Okay, we already have our, let me go back. We already have our mean and standard deviation. It's set to be between. This is what it defaults. We want to change the value here. We want the area between these two things to be 90%. So let's put in 0.9 or 0.90 if you'd like, and then let's compute. Okay, let's go back and look at our picture. Sure enough, we knew that most of it, 90%, was going to be shaded. This is the bottom 5%. This is the top 5%. This is the middle 90% in that case. And those scores, the 5th percentile score is a 325. And the 95th percentile score is a 707. So between 325 and 707 gives us the middle 90% right there. Delightful how it does that for us. Okay, so we can write that down and then do a brief sentence to interpret that. Okay, we knew it was between 325 less than X less than 707. 325 is the 5th percentile. 707 is the 95th percentile. Okay, so this is the middle 90%, 95 minus 5. And we're going to interpret this result. Well, we'll just say that. The middle 90% of math scores are between 325 and 707. So there you have it, using StatCrunch in two different directions, in this case, finding the value.